Salam Doctor and my teammate. This is Engineering Statistics Assignment 1, Recital of Productions of Lajakk Kurui-C, represented by Kuruih-C from Group C. So I would like to have the introductions and objectives. This report summarizes the data of productions of Lajakk Kurui-C, named PILL LAJAK KURUIH-C, December 2020. The objective is to describe the status of the production of the Lajakk Kurui-C, named PILL LAJAK KURUIH-C in December 2020. So for the part A, we did summary of the sample data of the 5 LajakLaku tablets, which is PILL LAJAK KURUIH-C produced in December 2020. The observations are presented respectively in numerical, tabular, and graphical form by using pivot table and bar graphs in Microsoft Excel. The summary included weight of PILL LAJAK KURUIH-C, relative density and tensile strength of PILL LAJAK KURUIH-C. For the weight, we use pivot table to have the summary done. So we have total of 69,830.86 milligrams and have the mean of 349.1543 milligrams. So from the graph, we observe that the maximum number of tablet is 32 with the weight of PILL LAJAK KURUIH-C in range 340 to 345 milligrams, while the minimum we can obtain is 0, 385 to 330 milligrams. For the relative density, we obtain in a percentage. The minimum we can obtain is 1 with the range 82.5 to 83%, while the maximum we can obtain is 37 with the range of 87 to 87.5. The median is 87.9, while the mode, which is the maximum number we obtain, is 87.5%. So last, for tensile strength, which measure in unit megapascal, the total we measure is 1,430.4 megapascal for 3 shifts, and the mean we get is 7.512. From the graph, we observe that the 82 tablets in the range of 7 to 7.2 megapascal is the maximum tensile strength of PILL LAJAK KURUIH-C, and it also has a mode of 7.1 megapascal, which is the maximum number of tensile strength obtained, and the minimum number we obtain in range 7.7 megapascal to 7.9 megapascal with 1 tablet marks the minimum tensile strength.
Hi, my name is Hazwan, and today I'm going to explain a little bit about part B, where we have to determine whether the Lajakk Kurui-C tablets produced in December 2020 followed the distribution of 350 mg of mean and with 40 mg of standard deviation. So the mean is required by the FDA, the Food and Drug Administration, that weights of standard tablets produced by manufacturers should be normally distributed with 350 mg and with standard deviation of 14 mg. So the mean and the standard deviation for the tablets produced in December 2020, which is our own data, is calculated using Microsoft Excel, where the formula is given, is provided in the Excel. So you just have to key in the formula, and we will also automatically get the answer. So the value obtained for mean is 349.1543 mg, while the standard deviation is at 13.1997 mg. And in order to recognize this, to categorize these tablets, we then produce a frequency table to categorize the tablets according to their weight range. So as you can see in this figure, in this table 1.1, we have frequency table where we separate the tablets according to their weight range by 10 milligram. So we have tablets starting from 310 until 390 to greater than 380. So our total count here is 200. So as example here, for instance, we have 310 to 320 for our tablets range. So we have 2 tablets produced in that range of weight. In that range of weight. Excuse me. After that, we can proceed to our hypothesis statement, where our HO states that the production weight in December 2020 follows normal distribution with a mean of 350 mg, while our HI states that the production weight in December 2020 does not follow normal distribution with a mean of 350 mg. So to determine that, we have to use Lajakk test because it is normal distribution, and we have to assume our alpha is 0.05 when the tablet's weight follows the normal distribution set by the FDA. And using the Lajakk test, we have Lajakk alpha over 2, so we will get 0.025, and by using the alpha 0.025, we will get 1.96 from the table, where the tablets fail to follow normal distribution set by the FDA. So what we have here is the formula or the equation. So Lajakk test is equal to x minus 350, which is the mean required by the FDA, over 14 divided by square root of 200. So the x here represents the mean of our tablets produced in December 2020. So it is 349.1543, where we obtained from our calculation in Microsoft Excel. So the final value or the final answer that we get here is negative 0.8542. So from this value over here, Lajakk alpha over 2, we'll get 1.96, and from there we will illustrate a normal cup standard normal distribution, so that we can determine whether the value lies between the region of the numbers or not. So since the value from the Lajakk test is negative 0.8542, so and the value for the alpha 0.025 is 1.96, so we can conclude that this value lies between these two regions. So from the Lajakk test result, we can conclude that HO is failed to be rejected since the value is between these two numbers. So the tablets produced in December 2020 did follow the normal distribution set by FDA, which is at 350 mg. Thank you.
For part C, we are required to comment on whether there is any significant difference between tablet weights from the different shift. First of all, based on the data given, we have 200 sets of data of weights, relative density, and tensile strength. So based on the data, we will sort them according to the shift, which are morning, evening, and night. And after we have sort the data, we will do the ANOVA one-way analysis using the Excel, and we will get the value here, and based on the value, we will comment on whether there is any significant difference between the shift. So here I have done the analysis. Based on the figure, the F test value is 0.2419, and the F critical value is 3.0427. So the analysis shows that the F test value is less than F critical value. Therefore, we will not reject the H now at 5% significance level. Hence, there are no significant difference between the tablet weights from the different shifts.
My name is Badru Aiman bin Abdul Rahim. I will discuss about the question D. So the question statement is, what is the prediction of the tensile strength for such a tablet? Comment on the validity of the model that you have used to carry out of this prediction. So this is as a summary output for regression analysis for summary output, ANOVA table, and estimate table. So from the regression statistic, we can know the value of R square. Mathematically, R square equal to SSR over SST, or 1 minus SSE over SST, which is the amount of the variability in the data explained or accounted for by the regression model. So the value of R is 0.861062,159. For the ANOVA table, the F value in the ANOVA table is the value of test statistic for F test, whereas the significant F is the probability of F variable being more than the test statistic. So the probability of F more than 567.744287 equal to 4.90078 power of time of 10 power of negative 60. In order to make the decision on the significance of regression, we can compare the significance of F with the chosen significant level of alpha as below. So significance of F more than alpha, we conclude that fail to reject the hash null. So the significant of F less than alpha, so reject the hash null. We choose the alpha is 0.01. The value of significance of F is 4.60078 times 10 power of negative 60, which is the lower than alpha value. So we reject the hash null and conclude that the data in this case provide a very strong evidence on the existence of the linearity in the regression model. For the estimate table, the information that estimation of the estimate of alpha and beta are represented by the row for intercept and relative density. For the value of alpha and beta, we can create the equation to predict the relative density. So therefore alpha is negative 0.5064989695 and beta is 0.089625183. The p value for beta is probability of t more than 23.8273853, which is equal to 4.60078 multiply of 10 power of negative 60. So this value is much lower than the chosen significant level or 0.01. Thus beta is significantly not to 0 at 1% significant level, which implies that the linearity between the two variables does exist. By using y equal to alpha plus beta at the equation that we use to predict the value of tensile strength corresponding with relative density value of 68%, 74.3% and 80.1%. So the result we can see from the table below. From the graph that we get from the summary output, we can see the tensile strength value seem reasonable value, which is relative strength increase, tensile strength also increase. So same pattern like graph obtained from Excel output and integration and interpretation, and also from the equation that we create before to predict the value of the tensile strength that corresponding with the relative density.